So, okay, so as I was saying, these are identities, but we use them, we kind of refer to them as formulas because of the way we actually kind of plug in and work with these. The radian measures, we're gonna wanna have kind of a reference of what they are, what they look like in terms of something pi over 12, just so that we can kind of make the comparisons and the combination of the values as we need to. So let's take a look at what's happening here. So here's what I want you to think about and realize, okay? These are equations. They look like equations. It's really not. It's an identity. But what I want you to think about is the fact that we might see something written like the left-hand side, and so then we're going to need to rewrite using the right-hand side. Or it might be that you're given the right-hand side to begin with, and then we have to rewrite it using the left-hand side. So we are kind of using it as a formula or equation, so that's why you're going to hear me use those terms. I want you to notice some specifics about this. If we are taking the cosine of two angle measures that are getting added or subtracted, I need you to notice it's not the case that we can just say it's the cosine of the one angle and the cosine of the other angle. If you notice, it's more involved than that. So those are our formulas that we have to use. Some things to notice. Notice that if it's the cosine of a sum or a difference, the sign inside on the left-hand side is opposite the sign of what it is in this formula. And I also want you to notice what I have in the pink here, highlighted in the pink here. The cosines are all together, the signs are all together. So to begin with, you're kind of like, whatever that means, I don't know what you're talking about, but you're gonna see that if we look at the sign formulas, they look very similar. You have to be able to distinguish between the two. So that's, I'm pointing out kind of the similarities and the differences between them. Okay? All right. So the task at hand is, it says find the exact value of the cosine of pi over 12. So what this is really telling us that we have to do is we need to use some of our special angle measures. We need to be able to add or subtract those in order to get 1 pi over 12. So I want to kind of go back over and look at this list over here that we've created with our common denominators. We need 2 radian measures with our common denominator that when we combine them together give us 1 pi over 12. So which 2 would you like to use? Izzy, what do you think? Okay, so you want to use the 5 pi over 6 and the 3 pi over 4? Is that what you said? Or did you say pi over 6? I couldn't hear what you said.
Maybe 3 pi over 4 would be better.
Okay, so we're going to use these 2. Is that what you're saying?
Yeah.
If we do 10 pi over 12 minus 9 pi over 12, we're going to get 1 pi over 12, right? Okay, so let's use those. I think I misheard you, but I'm not sure. But we're going to use those. We can use those. Okay, so I want to rewrite this cosine of pi over 12 as the cosine of, as we just decided we're going to use, that 10 pi over 12 minus 9 pi over 12. Only besides writing that, because we're about to go to our handy-dandy unit circle and look at what these values are, so it's going to be easier for us to see and figure out what these values are if we also write this using our reduced form of our radian measure. So besides that 10 pi over 12, let's really think about that now as our 5 pi over 6 minus our 3 pi over 4. Do you see that? Okay. All right, so we are trying to figure out the cosine of those 2 angle measures that we are subtracting. So we need to find which formula up here applies. And that looks like this is this bottom formula because this is the cosine of a difference of the 2 angle measures. So we've got to plug into this part of the formula then. So what it's telling us then is that we are going to plug in and find the cosine of the first angle, which is 5 pi over 6, times the cosine of the second angle, which is 3 pi over 4, and then plus the sine of 5 pi over 6 times the sine of 3 pi over 4. Okay, so I'm just plugging into that formula. Now we've got to go to handy dandy unit circle. Hola, I stole your seat. Okay. Thanks. Okay, so let's keep in mind on our unit circle, Maya, make sure you grab a unit circle from up there too. You're going to want that. Okay, we're going to our handy dandy unit circle. Remember, x values are our sine values, y values, x values are our cosine values, y values are our sine values. So to find the cosine of 5 pi over 6, what is that equal to, Ryan?
Cosine?
Cosine of 5 pi over 6.
That's negative square root of 3 over 2.
Negative square root of 3 over 2. Sounds good. And then the cosine of 3 pi over 4, Katie? Cosine of 3 pi over 4. Okay, something's missing there. Be careful. Okay, good. Negative square root of 2 over 2. Okay, and then plus, now we need to find the sine of 5 pi over 6. Rachel, what is that?
1/2.
Yep, 1/2. And then the sine of 3 pi over 4, Christian? Root 2 over 2. Okay. So at this point, we've got to clean this up. We've got values that are getting multiplied together. So if you multiply a negative times a negative, we know we get a positive. Square root of 3 times the square root of 2 gives us the square root of 6 over 4. And then plus, over here we get the square root of 2 over 4. So there's one last step we can do, and that is that we can put this all over our common denominator. So this is our final answer. So it looks weird, but that is it's an exact answer, and that is our final answer there. Okay? The tendency is to think that we should be able to combine those terms together, but they are not like terms. To be like terms, they have to have the exact same thing under the radical. So that is all the simplifying that we can do on that. Okay? So for what it's worth, all of the problems that you have where you're looking at something with cosines, if it's strictly an angle measure, your answers are going to look something like this, where you're going to have a square root of 6, a square root of 2, and a 4 in the denominator. So kind of keep that in mind. Okay, Maya, you had a question.
Oh, no. I missed the whole thing, so I just want to do another one.
Okay, all right. It's probably going to be helpful for you to get that copied also, because they put that maybe just like on the side of the page, or in the margin across, because that's what we started with. We put that way over here. Okay? Although, maybe hold off, let's do this one first, and then you can get that copy. All right, let's take a look at this one. So this one's a little bit easier in that we're not having to deal with those radian measures, those fractions. We need two angle measures that either add or subtract, two of our special angle measures that add or subtract to give us 75 degrees. Ariely, what do you think? What do you want to use? Any two angle measures that either add or subtract to give us 75 degrees. Okay, yeah, we can use 30 and 45. If you want to think of them as pi over 4 and pi over 6, you can. In this case, because we're in degrees, we can do just the degrees too. All right, I like it. So let's do cosine of 30 degrees plus 45 degrees. Okay, so we are looking at which formula? The first one or the second one? First one. How do we know that? Because we are adding them. So we're going to use that first formula. So that means we are plugging in, and we're going to take the cosine of 30 degrees times the cosine of 45 degrees, right? And then in this case, it's going to be minus the sine of 30 degrees times the sine of 45 degrees. And so once again, onto the handy dandy unit circle. So the cosine of 30 degrees, Preston? Okay, square root of 3 over 2. Cosine of 45 degrees, Christian?
2
Root 2 over 2, sounds good. And then minus sine of 30, Jackson?
1
Yep, 1/2 or 1 over 2 times sine of 45, Solomon? Okay, yep, root 2 over 2. So then we have to clean this up. So if you look at what we're multiplying in that first term, we get the square root of 6. And then second term, we get the square minus the square root of 2, and then all of that is over 4. So that is our final answer. So take a look, as I said, any of this type, if you notice, you're going to have a square root of 6, a square root of 2. Those are going to be in the numerator. The 4 will be in your denominator. So it's a matter of doing the work so that you can determine what the signs are going to be, plus or minus, that type of thing. Okay. Because but you're multiplying 2 times 2 in each of these. So then you do have that common denominator. Okay? Oh, good question. I'm glad you asked. All right. For sine values, if you look, I want you to look at these formulas because these formulas are a little bit different. And now you understand what I'm talking about in terms of being able to compare these and see. So if you notice, with the sine formulas, if it's minus in between on the left-hand side, it is also minus on the right-hand side. So the signs are the same. If you notice in the pink, what I've got highlighted, the sines and cosines are kind of mixed together, right? We've got sines and cosines together in the first part, sines and cosines in the second part. So the formula's a little bit different, which it should be if it's a sine formula instead of a cosine formula, right? Okay. This one, we're going to have a little bit different format because we are going to have to prove this. So I want you to notice we're going to have to focus our attention on this side, and we're going to plug in, and we better get for our final answer that it's equal to sine of x. So as you know, it's nice to know, okay, this is where we're headed for our answer. So we're going to have to use the first formula because it's sine of 2 angles that are getting subtracted. So it's a difference. So we are going to plug into sine of the first times cosine of the second, and then minus cosine of the first times the sine of the second. And so, I'm sorry? So we are, if you notice, the format that we're given here is this sine of 2 angles that are being subtracted. So it's a difference. So that's this formula here. It looks like this one, that top one. Do you see that? Okay, so then we're just plugging into this right-hand side. Does that help? Okay. All right, now we've just got to plug in. We've got to go to our unit circle, and come up with what the values are. So the sine of pi radians is equal to what, Rachel? 0. Yep. So we get 0 times the cosine of x, which we know that's just going to be 0. And then minus the cosine of pi, Izzy? What's Take a look again, careful. You're missing something.
-1.
Yeah, there we go. -1 is the cosine value at pi times the sine of x. All right, so what happens here, if you notice, is we have minus this negative, so that becomes +1 times the sine of x, which we know is just equal to the sine of x. So we do get that the sine of x is equal to the sine of x. So
Okay, what happens to the cosine?
if we're multiplying by 0, it just disappears. All right? Okay. So notice I kind of gave you some examples, kind of a little bit different. Some with radians, some with degrees, and then this one is one where you actually have to prove where you are given like x's and that type of thing in there. Okay? All right, I'm trying to remember. Okay, yeah, there's one other example up there at the top, and then we're going to take a brain break and talk about tangents. Okay? So, if you look at that example up on the top there, I have to deal with this. If you look at that example up at the top there, this is looking like the right-hand side. So you have to decide if it's the right-hand side for a cosine problem or a sine problem, and then kind of do some math here. So take a look. I want you to notice a few things. I'm seeing sines and cosines mixed together. So does that mean that we're looking at a sine formula or a cosine formula? Sine, good. So you know it's a sine formula. And if it's a sine formula, then if we see this sign as being positive, what does that mean? Careful, go back and look at your sine formulas. With the sine formulas, they're the same on the left and the right. So if it's plus here, that means it's going to be u plus v here. Okay? Do you see that? With the cosine formulas, they're opposite, but with the sine, they stay the same. So we want to add those. So we would need to put the angle measures in. So we get a 63 and a 27. That gives us that we are looking for what the sine of 90 degrees is equal to. So on this type of problem, I want you to notice, ultimately, you should be able to give me a final answer, a final numerical value, because we can go to our handy-dandy unit circle and find what the sine of 90 degrees is, which is 1.
Wait, why do we put 90?
Because if you add these two together, you get 90.
Gotcha.
You see it?
Yeah.
Okay.
I guess why.
All right, quick. Okay. If you notice, I've put a little note near the bottom here saying avoid using 30-degree reference angles or that pi over 6 if you can. So that's going to be true for these tangent values. I'm going to show you an example, one that does not involve a 30-degree reference angle, so you can kind of see the process. But I'm going to show you one specifically where we use the 30-degree reference angle or a pi over 6, just so that you can kind of understand why it's not ideal, because it just makes things a little bit messier. So you try to keep that in the back of your mind. For tangent problems, if you can avoid using 30 degrees or pi over 6, you want to. Or for that matter, any of the 30-degree reference angles, that means any of the something pi's over 6, right? Okay, the tangent formulas are a bit more involved if you notice. So in the numerator, we are adding or subtracting whatever the sign is inside the parentheses. It's going to be the same on the top. In the denominator, it's opposite sign, and if you notice, it's 1 plus or 1 minus, and then we're looking for that product. We're multiplying those together. So just a little bit about the formula before we actually plug in, okay? All right, so for this first one, we're trying to combine together to get 7 pi over 12. So we want to go back and look at our list of angle measures so that we can add or subtract to get 7 pi over 12. So in this case, I want to use, let's try this again. I want to use the tangent of 4 pi over 12 plus 3 pi over 12. And I'm gonna rewrite that so that I have my reduced fractions, so it's easier for me to, so that's saying we have the tangent of pi over 3 plus pi over 4. Okay. All right, and then to plug into the formula, what that tells us is that we are going to have in the numerator, we're going to take the tangent of pi over 3 plus the tangent of pi over 4
I thought you started.
all over 1 minus. Did you figure it out?
Yeah.
Okay. Okay. So that's what it's going to look like if we plug into that formula. It's the addition one, so it's plus on top and minus on the bottom. All right, now we need to actually plug in the values and see what we get. And we're gonna have to clean this up again as also. So the tangent of pi over 3, remember tangent is y over x. We don't have to worry about denominators. Remember those divide out if you were to keep it, change and flip it. So tangent of pi over 3, what does that give us? Solomon?
Root 3.
Yep, we get root 3 plus the tangent of pi over 4, Christian? So y over x. Root 2 over 2 over, yeah, root 2 over root 2, so we just get 1, exactly. Good. Okay, so we have square root of 3 plus 1 in the numerator over 1 minus, whatever you get in the numerator, those two values, you're going to multiply them together to give you that product, right? It's going to be the square root of 3 times 1, so we get minus the square root of 3. As you know, we cannot have radicals in the denominator, so we've got to rationalize. So we've got to multiply by the conjugate, top and bottom. So these are a little more involved because of this. All right, so we've got a FOIL on the top. So if we FOIL that, we get first is square root of 3, outside is 3, inside is 1, square root of 3 is last. Over, in the denominator, because we are multiplying by conjugates, you don't have to FOIL completely, you just have to multiply first and last.
Root 3 times root 3 just 3.
Yep, that's right. So we get 1 minus 3 in the denominator. Now we've got to look at what can combine together, what like terms we have. So those are like terms, and those are like terms. So we get 4 plus, I'm going to color code this, 2 root 3 over negative 2. So when you combine the orange together, you get 2 root 3. When you combine that blue together, you get that 4. And yet, we've got Mickey Mouse ears, don't we? Do you guys remember that?
Yeah.
Your Mickey Mouse ears?
It'd be negative 2.
If you have a common factor in all 3 of these places, you can divide it out. And so, yeah, we are going to want to do that. So we end up with negative 2 minus, you can put a 1 there if you want to, but you don't have to, root 3. So the tangent values look very different from what we saw with our sine and cosine values. The sine and cosine values look pretty similar. For all of these tangent type problems, this is what you're going to see. You're going to have a 2, you're going to have a square root of 3, and then you're doing the work just to kind of decide on the signs. Okay? All right. Questions on that before we look at this next one's gonna be a little more complicated because we're gonna have complex fractions. I want you to see an example of this so that you understand why I'm telling you avoid that 30-degree angle if you can. But keep in mind, ultimately our final answer should look something like that. Okay? All right. Tangent of 75 degrees, and I want to think of this as the tangent of 30 degrees plus 45. So tangent of 30 plus tan 45 all over 1 minus tan 30 times tan 45. Okay, so tangent of 30 degrees, we get 1 over the square root of 3, which you can leave it that way. It gets messy though. So square root of 3 over 3, which is how we rationalize that, plus 1 all over 1 minus, then we multiply those two terms together, so we get another square root of 3 over 3. So this is why it becomes more complicated, because now we have complex fractions, fractions within fractions here. So we've got to kind of clean that up, right? So here's how we're going to do that. Get rid of some of those. Okay. So first step is I want common denominator. So I'm going to rewrite these ones using the common denominator of 3. Okay. So I just rewrote those ones as 3 over 3 so that I have common denominator. Do you see that? So what that gives me is the square root of 3 plus 3 all over my common denominator. And then all of that is divided by 3 minus the square root of 3 all over my common denominator. At this point, we would need to do keep it, change it, flip it. And I need you to visualize what's going to happen if we do keep it, change it, flip it. The 3's in the denominator cancel out, divide out, and we are left with just what's in the numerators in top and bottom. Okay. So we just did that to clean up and get rid of the fractions within the fractions. Now, though, if you notice, so that's what all of that work was. Now we still have radicals in the denominator, so we still have to multiply by conjugate. Yep, so 3 plus square root 3, you got that right. There you go. And we're going to have to FOIL and FL and simplify, right? So first, outside, inside, last, all over FL, which is going to be 9 minus 3.
What's the trick to the bottom again?
Just first and last, because the inside and outside are going to add to 0. So we get 12 plus 6 root 3 all over 6. And once again, we've got Mickey Mouse ears. And 6 goes into 12 2 times, plus 1 times the square root of 3. Okay. So it's doable, it's manageable. You have to be careful with the math, but that is definitely more complicated than what we did for that first one. The first one's complicated enough. This gets really messy, and it's because of this 30-degree angle or this pi over 6. So if we can avoid those, we definitely want to. Okay? All right, onward. 2 last things to look at, and then you guys can get started on homework and work with your partner on that. Okay, take a look at what this is saying here. This looks like the right-hand side, so we want to rewrite it so that it looks like the left-hand side. So it's definitely a tangent problem, right? And we need those 2 angle measures. I'm seeing that it's minus on top here, so I know it has to be minus here. And then we've got to plug in the angle measures, so we get 78 and 18. So that simplifies to just the tan of 60 degrees. And you can go to your unit circle and find that value on unit circle. So that's what I would be looking for, is that final answer. Okay. On this one, depending on what the directions say, it might be asking you to, it might want you to like truly plug in the values and come up with what your answer would be, which in this case, I'm just gonna write that off to the side just in case you wanna try that one. But the other thing that it's probably, most of the time what it will be asking for is for you to figure out, is this a sine or a cosine? Is it a sum or a difference, and add or subtract? So we've got sines and cosines mixed together. So we know that that means it's a sine formula. And with the sine formulas, if that's plus, then it's plus in between the 2 angle measures. So we're gonna add those 2 together, finding common denominator and adding those, you get that what we're really looking for is what's the sine of 7 pi over 12.
You have to bring all the way to something over 12.
Yeah, this would be final answer for that. Common denominators, you'd have to get common denominators, which would be 12. So 4 pi over 12 plus 3 pi over 12. So you got the 7 pi over 12. All right.
What was example 3?
There we go.